Now, while you guys are writing this down, I'm going to go ahead and quickly just re-emphasize what we've done in class today, because I just totally forgot to hit the record button, so the people that were gone today cannot get the beginning of the lecture. So you guys are trying number 1, writing down number 1 and 2. We'll get to 3 in a second. So one more time. People in the video, go ahead and pause me if you need to write down any of these notes and then going over and I'll show you what we did. The goal is to complete the square. So we're going to have an incomplete statement, an incomplete expression, and we want to be able to eventually get that expression to look like this binomial square. That's why we have to complete the square. No, it's okay because you guys have already got this. It's showing up on mine, so it's showing up for them. So our goal is to make a perfect square trinomial, but guys, hold on, this will help you in number 1. We are given what? Is it a trinomial or is it a binomial? Binomial. Binomial. So we need to go ahead and put, ready? Plus blank. So x squared plus 10x plus blank for those of you guys doing an example. We're going to do plus blank when we see a binomial and we need a trinomial.
Okay, that makes sense.
How do we fill in that blank? With a special little formula that says take the middle coefficient and do what to it? Multiply by 1/2 or cut it in half. But that's not enough. We multiply by a half and then we square it. Good. Cut it in half and then we square it. We add it in. And then we had some examples that we did at the beginning of class of filling in that blank by taking the middle term, cutting it in half, and squaring it, filling in the blank. Same thing over here. And then to factor, well, there's a special way of factoring that we'll review in this example. All right, kiddos, thank you for your patience. Let me come on back. Let's see how you guys have done. So for number 1, did you guys put your, hey, it's not quite a trinomial yet, plus blank?
Yes.
Good.
Even if it doesn't say like plus C.
Well, it's going to say complete the square.
If it says complete, then you have to find
Then you have to say it's not complete, I'm missing blank. Does that make sense? That's where it got a little harder, Angels. They're not saying plus C. We have to know, uh-oh, we're not.
Let's do it. -4 squared.
Well, hold on, wait. Robert, we're taking the 10 first. Number 1, you're on number 2 too.
Okay.
Take the 10 first. What are we going to do with that 10? Multiply by a half and then square it.
5.
What's a half of 10? 5. That's 5 squared.
25.
So, to complete, ready? We have x squared plus 10x plus who?
25.
Plus 25.
You have to show work.
Show work just so we can get it to stay in your head. Math, sometimes the hardest part isn't getting it in class, sometimes the hardest part is getting it on your own at home, like in homework. Or, even worse, sometimes the hardest part is on the test. Now kiddos, wait, pause. We did complete the square. The problem is we did not yet factor.
That's true.
Now, we could go to like tables and stuff like that, or we could just say, wait a minute, hold on. On the page before, it said that we could put x plus, and we could steal whatever number was there after cutting the middle term in half.
But see, that will be our final, the box answer will be our final answer.
For completing the square, but then there's another step that says then factor. So we're doing part 2. Now pause, look on the page before.
Yes.
It says x plus 1/2 of b. So we take that 1/2, but wait. What is 1/2 of 10?
5.
So we can just automatically plug in, and it's a positive 5, so we keep it a plus. These two are exactly the same thing. This perfect square trinomial factors to be x plus 5 squared. Now, how can we check that? We can FOIL it and see if it actually works. But this is just a checking step to make sure that you guys understand these really are the same. And once again, I just did what the step in the page before told me to, which was, if it helps, we can actually write that out. What I did was I plugged into the formula x plus 1/2 of the middle number, not squared, with the square on the outside. And that's how I ended up getting to the factor form. Now to check it, this is just the checking step. to check and make sure it works, we could go ahead and practice our foiling and say, hey, does this actually work? Remember, we have to write it out. X plus 5 times x plus 5. Don't want to kill a puppy. And x times x is x squared. Alright, come back on it. Outer. Angel, why aren't we looking? Josh, why aren't we looking? Ian, why are we making noises? Inner plus 5x. And then last plus 25.
Do you have to check or not?
Well, I'm just trying to show you guys in this one example that it really does work. Some of you might not see it. Does it work, guys? Yeah. Here you go. What's your question?
So, there is going to be two answers, right?
There is what?
There is going to be two answers for the opening.
For these directions, yes, because these directions say 1, complete the square. 2, factor. Does that make sense? So 1, complete the square. We answered that in completing the trinomial. And in this one, 2 says factor, and we did that by factoring. Does that make sense? Okay. Now, number 2, Rob, you started saying this one a second ago. Let's go ahead and move to number 2. Because what's the very first thing we should do? Looking at the other example. Rob.
Take the 4 down and put the 1.
We are going to take the 4 down. That's good, except, hold on, even before that, we have to remind ourselves something is missing and we need to fill it in. Plus C you can do, plus blank you can do. We need to fill in the missing piece. And we need to see it's missing before we can finish it.
It can always be plus C.
You can do plus C or plus blank. They mean the same.
No, because it always be plus.
Well, actually, it is always going to be plus, and here's the reason why. Even though the inside number might be plus or minus, when we square it, positive squared is positive, negative squared is positive. So this will always be a plus whenever you're completing the square. Okay, so, Rob, you already said take down the negative 4. You did a good job seeing that it was a negative 4. What am I going to multiply by? Everybody. Ian, what am I going to multiply by? A half, but is that enough?
And then you do the square.
And then I square it. PEMDAS tells me, take the half first. What's a half, Justin, of negative 4?
2.
Thank you.
Negative 2.
Good. And then Dylan, if I square negative 2, what's negative 2 times negative 2?
4.
Okay. And that is the number that I plug in to complete my square. Are you guys seeing it?
Yeah.
Yeah.
I know,
What?
Because we have to just rewrite what was given to us at the beginning. So since this one started with x squared minus 4x, we could do plus negative or the original minus. We just have to keep this the same. We're just filling in, not changing. Does that
Would
make
it be
sense?
plus minus? No. Plus minus 2.
Not plus or minus 2.
No. He's talking about like plus.
Oh, plus negative 2, yes.
why did it turn negative with 4x?
It didn't turn negative, it was
Why do you
negative.
have the minus?
Look, it was minus to begin with.
Yep. Oh, so
See
you
it?
start the whole
I
problem.
just changed the minus so that we remembered it was a negative number. But it was a minus to begin with. Caleb, come back up to the angel. Now, we need to go ahead and factor. And guys, to factor, we do x plus 1/2 times the middle number was negative 4. What's going to happen when I take 1/2 of negative 4? What did happen up above? Okay, so do you guys notice that maybe we don't have to do this all over again? Maybe we can just steal the middle number?
Oh.
So we could do the 1/2 times negative 4 all over again, or we could just take that middle number, which is x. Why is it minus?
Because it's a negative.
Because I'm adding a negative. So when I add a negative, it's going to be a minus. I have just, once again, completed the square. You guys see it?
Whoa.
Whoa! No.
So my iPad just died. That's really sad.
Oh, it died.
Now,
So it says
as I try to bring it back to life, I thought it would last all of class, but it didn't. We still have 10 minutes. Guys, hang in there. Okay. We have one more big thing to learn today, and we might do another example problem at the end if we can get to it, but actually we can do it right here. Do you guys think you can do this?
Number 3.
Number 3. Kiddos, you have numbers 1 and 2 to use as a model. Now try number 3. Now try number 3.
I already tried. I can't.
It's hard. Why is number 3 hard?
Because 7 is always going to 3.5.
But there's no stress. Even though it's a fraction, okay, it's a little bit harder, but we still use the exact same procedure.
Yes.
Okay? So,
I can't. This is hard.
we still follow the system. We still take the 7. We still multiply it by a half.
It has to be a fraction. Fraction.
Yeah. Now, 3.5 is Lilio. Listen. 3.5 is really hard to square in your head. But, what if you can't use your calculator? Now listen carefully one more time. Hold on. If you had to do it mental math style, 3.5 is really hard to square because you would have to literally set up 3.5 times 3.5 and do 2-column multiplication with 2 decimal places. So, for those of you that are like, that doesn't sound fun, here's a better way of doing it. You can put 7 over 1. And you can just leave it as a fraction and not have to go to a decimal and say, what is 7 times 7? Because it's 7 over 2 times 7 over 2. 7 times 7 would be 49. And what's 2 times 2? 7 over 2. Rob, focus back on it. 7 over 2 times 7 over 2 is 49 over 4. We square the top, square the bottom. That had to do with exponent rules that we covered earlier. And then we say, okay, it's ugly, but I can still do it. I fill in x squared plus 7x plus 49 over 4. I know it's not pretty, but guys, you should box that answer because it is a good answer.
I just 12.5.
Well, remember we're plugging in C. I think it should be 12.25.
But I had a 0.
So 12.10, Jordan, is a little bit off, so we don't want to put that. 12.25 would work. Now, kiddos, if we want to factor, now here's where it really helps. It would be really hard for us to factor this, even in a table like, 49/4 is disgusting, but we could say x plus, and we can just steal, remember? Steal this inside number, which is 1/2 times 7. Not just 7, we need the 1/2 times 7. And we can say 7 over 2 squared without having to do any crazy factoring with a table or anything like that, because we know how complete the square works. You find this special number, 1/2 times 7, you square it, and that's what completes the perfect square trinomial. But you don't square it if you're just trying to factor. Yeah. So, as Jordan is saying, this could be 12.25, this could be 3.5, and it would be the exact same thing but in decimal form. But once again, our trick, not even our trick, our process works even if we have fractions. Now, here's the second big idea, and this is actually something that Angel brought up earlier. What do we do if we have an equation?
Look, I put the numbers in the left. Yeah.
But wait, we're actually getting ready. Now, kiddos, we prayed for strength.
Yes.
I prayed for patience. I just didn't say it out loud. We need to make it through this class period so you guys can get to lunch. But some of you are about to lose your lunch. You can just do math with me the whole time. I'd rather not. I'd rather you have lunch and get a break. So let's go. You need to write down, word for word, solving with completing the square. And move back one real fast. I'm not sure what's going on. Too sure, Kathy, you just need to focus.
Feels good morning.
To use an equation. Show you real fast.
Was 15 BC?
No. It would substitute the C if it was. was the special number that's 1/2 and squared, but it's not. And we'll see that in a second. Completing the square actually opens up new possibilities for us in solving equations. Some of you are like, add the 15 to the other side. And you're right, in that we could add the 15 and we'd have to factor the old-fashioned way with a table. However, there is another way without adding the 15 to the other side. And in the directions it would say solve with completing the square. Okay? Those would be the special directions that you have to follow. In order to solve with completing the square, we'd say, you know what, the x squared minus the 16x, he's missing something. Yeah, we're getting there. Hold on. There's a really important concept before we ever get to the 1/2 and the square.
Do we solve for the whole thing and get what x equals?
Yeah, eventually. So, if it says solve, and it's going to say solve with completing the square, okay? So this is a very special way of solving. Solve with completing the square. We're going to say, okay, we see a binomial, but we're missing a blank, so we put in the plus blank. On this side, we have to write the negative 15 because it's there, but guys, hold on, in algebra, does it make sense to add something to one side of an equation and not the other? Is that legal?
No.
So what we do to one side, we're also going to do to the other, just like we always do. Now, once we have this set up, then we say, let's go find our special number that we've learned how to find. So, we're going to say, let's take that negative 16, right? Because it's minus. Let's multiply 1/2 times negative 16, and let's square it. So we take the middle number. It's okay, right here. Take the middle number, cut it in half, that is going to be negative 8. When we square it, that is going to be 64. So then we're going to say x squared minus 16x plus 64 equals. Now, if we fill in this blank, what do you think we're going to do with the blank on the other side? Fill it in the same way. Now, negative 15 plus 64 does end up being 49. But it's still really hard to solve with a perfect square trinomial. That's really hard to solve unless we say, wait, we can factor that. And we can factor that to be x, remember, go back and look before the square, minus 8. This could be easier to solve, to finish. In order to finish this expression, we're going to have to say, wait a minute, how do we undo? We want to get to x. How do we undo a square? Square root.
This one was
What we do to one side, we do to the other. Now this is what we were doing before break. This was on the quiz.
I don't remember.
We square root to undo a square. We need a plus or a minus since it's a positive number. The squared and square root undo each other. And we end up with x minus 8 equals a positive 7, or x minus 8 equals a negative 7.
Or can you just make like the plus?
Well, we need to keep going, so we can't just do plus minus 7. We need to keep solving. Jordan, eyes back up here. So we need to add the 8 to the other side, and we end up with a 15. Or we add the 8 to the negative 7, and we end up with a 1. So we end up with two different answers. X equals 15.
Or what?
Or 1. You can put the or, you can put a comma. We've done commas before. X equals 1. Because the point was to solve for x. Now, kiddos, eyes on me. There are a couple examples on the next page. However, we're going to use those as our warm-ups tomorrow to see how well you guys were able to work on this tonight. Homework for tonight, let me show you the homework. I'm going to write it on the board first. Hold on, no one's leaving until we write down homework.
Let's do it.
I'll show it up here on the big screen, okay? These problems are going to be warm-ups tomorrow before we keep on going in section 9.4. So do the best you can on homework tonight. Now listen. If homework tonight is a big struggle, get as far as you can. But then we might do what we did before break, and we might add on a few more problems and turn in the homework all together on Wednesday. Sound good? Okay, so do the best you can tonight. You guys may now leave. Thank you for waiting. Remember, you're taking your quiz tomorrow. If you were absent on Thursday.
What a shame. I thought
You didn't wait?
You didn't win.
No, this is how you do it. Come here, big boy.